Okay, thank you. So, as I told you, Navigator is now our first bathymetric LiDAR product for UAV, and we are very proud to present it here. First, a few words about the company and its history. So, actually, our mission, what we gave us at the founding little more than a decade ago, is to provide the most integrated and easy to use UAV LiDAR solution for survey and mapping. So we usually work for for IRL UAVs. Some of our equipment is also used on cars and boats, on manned planes. But the most of our customer use UAVs. And our commitment is also to listen to the user feedback and to improve our products from actual field usage feedback. As we started being ourselves surveyors, it's very important to us. So the values of the companies are ambition for excellence. We always want to aim at high goals, and for example, one of the goals of our CEO is to put some LiDAR survey to a Mars mission, so in space, so very far from ocean, to trust our people. So everyone brings value in the company. This is a employee-owned company, and we try to move things uh, all of us, and have the best possible team spirit. So the company history, actually, it was launched by two people, mostly Tristan Alvis and myself. He was a specialist of LiDAR data, and myself, I was a hydrographer. But our first market was topography. So we launched our first product in 2014, incorporated in 2015, had two subsidiaries created in US and in Japan in 18 and 19. And now we are growing larger. In 2021, we bought a factory building to be able to assemble our systems. And in 2024, we launched the Yellowscan Navigator. We have 70 employees on 4 continents, and the R&D is really the heart of our projects. We more than 1/5 of the people working at Yellowscan work on R&D, and we invest a lot of the profit. We reinvest it to the team. So now let's go into the technique. So our products are laser scanners, basically. They are a system using one or several laser heads, sending signal to objects, which can be topography or seafloor, and measuring the time of flight of the signal coming back to have the distance. At the same time, we measure the angles and the position so that we can position in 3D all the measurement points. The order of magnitude is, I would say, between 20,000 and 2 million points measured per second. So it's very effective systems to measure topography or to measure bathymetry. Our products are fully integrated with embedded battery and easy setup, so that everyone can put that on a UAV and make some survey with it. Our motto is just press the yellow button. because we tried to simplify as much as possible the process on the field in order to make it feasible also in tough conditions. The systems are compact and light, of course, because they are built to go onto UAVs. Our lightest system is 600 gram and the heaviest is about 4 kilograms. And there was a really break a few years ago when we decided to make some bathymetric product because, of course, Tristan and myself, we were really fond on making something which is on the coastal area, which is much more interesting for us. We started to screen all the available sensors, but no one could reach our specifications. So we started to hire people to develop our own optical subsystems for bathymetry. And so we developed the laser source with the telescope. We developed the acquisition system so that actually our system now is quite unique. And by the way, yes, the research project we had internally was called Alligator in order to make bathymetry. It brought us some strange issues because at the Japanese border we wanted to import the alligator, but they told us no, it's a protected species, you can't import it. So we changed the name into Navigator, which is more neutral and no protected species until now. So it's a system which can do both topographic and bathymetric surveys. It's using a green laser. So green is of course reflected by ground, so it's no issue. And green also penetrates quite well the water. It's kind of echo of Emmanuel Boss's presentation about how the water penetrates sorry, how light penetrates water. Actually, the green-blue light is the best compromise to have uh, long range into water. Long range is a few meters, actually. So we have a easy mounting of the system to any drone with the GRIMC, which is a standard connector. And until now, we have about 2 Secchi depth capacity. So the Secchi depth is the depth where which characterize the turbidity. So 1 Secchi depth is the depth where an object disappears from your view when you look at it. So we can go twice as deep as that usually. So I would say typically in some turbid water, it's 1 meter to a few meter. In quite clear water, we can reach up to 20 meter. So the applications are river flood risk modeling, habitat modeling in sweet or salty water, coastal oceanography and engineering, harbor and dredging surveys if it's not too turbid, and also can help to dikes and breakwater constructions. We have also some uses for hydraulic energy structure safety, for example, the studies of dams for electric power. And so we have integrated it on several single motor and multi-rotor UAVs. Here are the system specifications. We have today a precision of about 3 centimeter. The depth, as I said, 2 Secchi. Actually, we choose to make some a little bit complex patterns with the laser in order to cover the area with different angles. Because sometimes you have shadowing by some obstacles, which would impair the possibility to see the bottom. So that with these patterns, we can see the bottom through different angles while the UAV is flying forward, so that we can have very few shadows. Okay, so today our wavelength is 533 nanometers, which is quite one of the standard laser wavelengths, and also the most suitable for water. We are still, I would say, investigating some other but quite near wavelengths to see if in some type of waters, for example, more turbid, we could improve the signal by having, for example, dual wavelengths. The operating altitude above the sea is between 25 and 100 meters. The scanner field of view 44 degrees, and the pulse repetition frequency is above 20 kilohertz. So you get 20,000 raw measurements per second. Of course, after that, there is a lot of signal processing because we have to filter out the surface echoes, which are quite strong. We have to find out what is backscatter from the water column and what is backscatter from the bottom. And so I would say the main challenge today for us is the signal processing. We are working together with universities to improve that. Here are some examples of integration. So actually, mostly on the same drone, sorry. We have integration on several drones, but basically it's always the same system, which is underneath a flying object. And here's some example of results. We started with working in Japan because our Japanese subsidiary had a very strong demand for bathymetric survey. So you can see reverse surveys with I would say the typical speed of the UAV is 5 meters per second, and so the flight could last between 10 and 20 minutes. So typically, I would say we cover half a square kilometer within one flight, and with this Japanese team, which made the surveys on the left, they fly sometimes like 10 flights a day. So it's quite a productivity tool when operated like that. So in the ocean in Japan also, we were very happy to reach for the first time 18 meters, which was at that time our record. And we had also some surveys in rivers and in coastal areas in France, working together with the French Research Institute. For now, we have built several systems, but it's still the starting phase, I would say. We have not like our topographic systems, which are used by hundreds of customers. For the bathymetric system, we have still a few selected customers with very high ability to process the data. The data is acquired full wave, which is it's a kind of LiDAR scanning jargon, but it means that the full return of the wave is scanned at very high frequency and recorded, so that it can be post-processed and improved on a desktop afterwards. So this is a very interesting features because most LiDARs just take echoes with an automatic procedure. And with this post-processing, we can, for example, get data out of what's happening in the water column, or data about uh, bottom in areas where the signal noise ratio is not so good. So yes, just our motto, just press the yellow button. So the Yellowscan systems are quite easy to use, and we are working at the R&D level to improve this ease of use. So we are quite interested in cooperation on the post-processing of signal, but possibly also on, I would say, more theoretical level on light object interaction in the maritime environment. So that's it. If someone has a question.
Ok.